Okay, thank you from my half also inviting me here. It's very nice to have so many people here. My name is Jarkko Sireeni. I'm working as a product manager for Viasys VDC. I come from a company called Topcon. Topcon is actually focusing on construction automation and survey. So we are making the digital construction 4.0 into reality. And if we think about the construction process, we start always documenting the existing. And that's why I'm talking about the city models today. And when you go to automated construction, there are already some places in the world that the construction is completely using robotics. So there is no humans on the site, only robots making the construction. And to make that working, you need to have digital models. You cannot automate a construction site if you don't have digital models. So that's why I'm talking about also BIM in design and construction. So that's my background and the company. I am having a presentation on behalf also Jarmo Suomisto. He's the project manager in city of Helsinki. He's the kind of the father of the Helsinki city model. And then I will tell you how we utilize the city model in the design and construction. So Helsinki 3D Plus, it's an open city model. So idea of openness was very important in Helsinki, so that if you have a city model, the data of the city, it has to be openly available for everybody. So they publish the data open. There is a video, animation video made from the city model, so you can see that it's very realistic, quite accurate 3D model of the existing. And it covers the whole city, and it covers everything what is above the ground, everything that is visible above the ground. And here is the web address, so all the data is available online for free, for open. This is a process how the city model was created. There are actually two different kind of city models from Helsinki. There is this kind of a reality mesh model, which is kind of a visualization model of the city. And then there is a CityGML standard, which is an OGC standard for city modeling, a real object-based information model, semantic model of the city. How they created it is that they had a lot of laser scanning and also aerial photogrammetry about the city. They used that to create a 3D geometry of the city. They also have a lot of different GIS databases where you have a lot of attribute information and information about the elements and a lot of registers that they combined with a 3D geometry model. So then they were able to create this CityGML model. They also had processes how to use IFC and infra model, which are kind of a BIM for infrastructure, to convert that data into the city model. So whenever an architect makes a design of the building, that can be updated to the city model. So using these formats, it's possible to keep the city model up to date, which is of course important. I have seen quite many city modeling projects that you create the model, but then you don't update it. So you need to continuously update the city model. So it's always a real-time picture of the existing situation. Then they had the application layer here that when they open this data to everybody, they not only use it internally in the city, but every contractor, every design company doing anything in the Helsinki city can use this data as an input for the design, input for the construction. But also, they invested quite much money into this. So Helsinki was thinking that once they publish the data open, that can create new business. And there was a portal of different kind of applications that are kind of using the city model. New kind of innovations and new kind of businesses generating in the city of Helsinki. And of course, when new businesses come to Helsinki, that means also tax income to the Helsinki. So it's kind of a business idea also behind the city model. So here are the difference between the mesh model, which is a reality model. It's a three-dimensional visualization of the city. It doesn't have any information, but then the CityGML model is a semantic object database of the city, combining all the GIS data. So you can go and click on the building, you get the building ID, the purpose of the building, the owner of the building, and all this kind of information about these elements coming from the registers and everything. And all of this is visible to the public. So if you go here to this address, you can, with a web browser, just look at the model and click on the elements. And you can also download the data into your own design software and use it there. They made also analysis of where you can use the city model and where is suitable and where is not. So here we have a lot of different kind of use cases and also different kind of data sources, and they just mark with the different colors how and where the city model is usable. I'm not going to details in here. One interesting application of the city model is that you can calculate the solar radiation in the city on different surfaces. They make this kind of calculation for all the buildings in the Helsinki, I think 60,000 buildings maybe. You can click on any surface and you can get the radiation data, that how much solar energy you can produce in different surfaces of the city. Because quite many cities, also in European level, are planning to be carbon free. So using solar energy is one way of kind of producing so much energy that you don't use any carbon. Open standards was kind of starting point in the Helsinki city model. CityGML is a standard developed by OGC. It's a XML-based standard. They're using also IFC, which is a building smart standard for mostly buildings, but also in the future it will be a standard for infrastructure. There are these development projects, IFC rail, IFC road, IFC alignment, IFC bridge for infrastructure. They also use this InfraModel standard. InfraModel is a developed version of the Land XML standard, but it's developed further in Finland to have additional information. Also in European level there is InfraGML standard and some other standards. So how we see the thing in this BIM world is that we are going to have multiple different standards, and to make the BIM work, especially in city areas where you constructing both infrastructure, buildings, and you have a lot of existing. So you need to have this kind of hybrid model of multiple standards. So it's not possible to do everything with only one standard. Another aspect also for the city model is that it's very easy to make the technical part of the city model. That's very easy, and it's almost automatic process of making a city model. But the most important thing is the social part, how you use the model, what kind of processes and what kind of workflows and work practices you have. So, and I think the biggest challenge in developing BIM is to develop these. This already exists. That's the easy part. One thing also with the Helsinki city model is that they had some requirements for the data. The data is always validated and maintained, so you can trust the data. So the data doesn't have any errors. It's in standard format. You have the infrastructure to deliver. The data is open for everybody to use, and it's integrated already into the processes internally in the city of Helsinki and also externally. So then we go some practical examples how you can use a city model. This is the basic of the CityGML format. In CityGML you have the city model in different accuracy levels. There are 4 or 5 different accuracy levels. Different levels are suitable for different purposes. For example, this mass level LEOD one is maybe suitable for area planning, but for architectural planning, you need to go to level 3 and 4. So you can use the city model in different applications and kind of choose the level of data you need. Also, the mesh model you can create from area photos. If you fly over the whole city, it's very easy to make this kind of mesh model. You can also, in smaller areas, use the UAV technology. So you just fly with a UAV and you can automatically generate more accurate, very detailed, almost even centimeter accurate models if you need. The difference here is that these mesh models, they don't have the information, so it's only geometry. The city GML has the information also. Quite many city models also focusing on the what is above the ground. Oh, the video is not working now. Okay. So we make a pilot with Helsinki. So there was some service tunnel under Helsinki. We laser scan it, and from the laser scan point, we create a 3-dimensional model and put it into game engine, and also integrate that into the city model in city GML format. So you can see that we make this 2 different detail levels of the underground city model and integrate the underground service tunnel network into the city model. So city models are not only anymore what's above ground, but what is underground. So here is an example of when you start an infrastructure construction project, you always make survey about the underground conditions. So combining the city model with the underground conditions, here we had a model of the surface of the rock bed, the clay, and also the surface of the seabed. And this is kind of the input for the design. And we also analyzed that actually the terrain model in the city model is accurate enough to be used in the design. So city model is automatically input data for the design process, because typically when you start a design project, you need to survey. And every time you start a project in the same area, you survey again and again. But if you have a city model, you already have that data available. So that's a real cost saving for any design project once you have the data available. Also, modeling of the structures. They make in this project modeling of all the bridges and walls in the area as a BIM model, as an input for the design. And also the modeling of the underground pipe network. They use different kind of GIS databases. Some places they make the hole and make the survey, and this way they can model the underground pipe networks. These are very important because a lot of cases these are the problems causing in the construction, that you don't know what's underground, and once you know, you can plan the construction much better. You can also use city model in area planning. So this was an area plan design made in MicroStation in 2011, and this is the real situation now in the city model in 2016. And I had to say that architects working in the area planning were quite accurately defining what's happening in real life. So that plan has been a success. Here is also an example of the area plan combining with a schedule. So here is one area in Helsinki city. They are building this whole area from the scratch, and maybe the construction time will take 20-25 years. So then you can actually simulate with the schedule, with the 4D model, the city development. You can use it for simulating it into the future, but also you could record the history of the city development. So time dimension is quite important, and if you thinking selling apartments here, you want to show how the area is developing over the time to the potential buyers. You can also combine the area plan and the IFC architectural designs. In some projects, they want to check that the area plan has some restrictions about the height of the building or the dimensions or some limits. You can check very easily that if the architectural design is fulfilling these requirements, and also just visualize and bringing the architectural designs into the city model. There is another example of the InfraBIM and bridge combined with the city model. So this is a typical input data for the design. Then you have the design of the bridge, which is one person making the design with the bridge design software. Then you have another designer making the design of the road design or street design in another software. And also there is some underground drainage and pipe networks. That's also another software. So combining all these together kind of forces the kind of BIM collaboration between the designers. So that is the idea with BIM, that the designers will collaborate and you can see how the structures evolving, how the road and bridge fit together. And also if we go further on, you can see some how the pipe networks fit into the road design, if the manholes are in correct elevation, and checking the quality of the design. And also the typical situation in the construction site, if this hasn't been done properly, there is a small pipe here which doesn't fit into the hole in the wall, and it's not even in the correct place. And this was actually a real situation on the site. So they actually had this problem. And the idea in VDC and BIM is to simulate all these in advance before you go to construction, because the cost of fixing this in the construction phase is 1,000 times more expensive than in design phase. And they actually have calculated that I think in building industry, the cost of clash is something like $17,000 US. And in Norway, in infrastructure, they calculated that the average cost of this kind of clash is about $10,000 US on the construction. So whenever you find this kind of problem, you probably save a lot of money. Here is another example of combining city model, BIM, infrastructure, and also as-built. This is the project, underlying metro project from Helsinki to Espoo, built in the rock underground. So you have the city model. You can see the BIM models integrated into city model, where the entrances are, where you go inside the metro. When you go more underground, you can see that you actually have a metro station. It's actually a building, so you have all the ventilation, electric, water systems, structural models, combined with the infrastructure design model, which is the railway. And as you can see here, the gray part here is the actual rock. So once they construct the metro, they blast the rock. After they blast the rock, they laser scan, and they bring the laser scanning here and combine with the design BIM model, because they want to check that the construction actually fits to the actual rock surface. So here you can see the actual rock that was blasted, and you can go very easily to see if you can actually construct the structures. And it's very expensive if they don't fit here, because the rock is very hard here, and the contractor changes, and the new contractor come and building this element, and they don't have capability of fixing the rock. So then you need to invite the contractor of rock blasting back, and that's very expensive. So you need to check all of these before you go to construction. They also use it for quality inspection, so they have the design model and the actual as-built model together. There are some design rules, for example, railway, that the rock cannot come too close to the rail because otherwise it will hit the train. So they need to check that the rock blasting fulfills these free space requirements. It's very easy to check with the BIM model. And the final purpose of this model is actually maintenance. So we collect all the data from the design and construction to be used in maintenance, because at some point they need to repair, replace, or expand. So then you have a digital model as an input for that future development. And here the last example of, actually second last. Sorry, this takes a bit more time now. These videos here. This is a contractor in Paris. This is part of the Paris ring road. Very tight area. You have the city model around you, so you have very limited area of building the construction. You have a lot of different phases. You need to make sure that the construction machines fit working in this area. You need to make sure that the traffic is always going fluently around the construction site while you're making the construction. So making this kind of 4D model to analyze the constructability of the project is very beneficial, and you can have a lot of cost savings in construction if you make this. Combining the schedule with the model. And last example is from UK. There is a Skanska. There was a small roundabout project. This is the design model. So they have the roads, the landscaping, and the bridge design model. And what they want to do is to use it in quality inspection. So they fly with the UAV around the site. They combine the UAV 3D model, which is kind of a reality model of the site conditions during the construction. And depending on how you fly, you can get very accurate models. And once you have very accurate models, you can do digital quality inspection. So you can compare the design and the actual construction. Does it fulfill the design requirements? So here you can open up and you can then zoom in and measure and see the differences between the actual situation and the design situation. And once again, this is a very good tool for the contractor to record the history of the construction. So especially in America, you usually go into legal things after the construction, and once you record the history with the reality models, you can show what actually happened and probably help you with the legal issues, if there is any legal issues. So you have a digital document what you actually did during the construction. And of course, models, you need to be able to use them online, mobile. We have technologies like augmented reality. You can actually go with the model on site and see what's underground, what is the design looking, how it fits to the current environment. And I'm going these very fast, but for the future of city models, most of the city models are everything what is above ground, but when you make a city model that would be usable for construction and design, you need to think also about what is underground. City maintenance process, how to update the city model. So don't only make a city model once, you need to think about the continuous update of the city model. And thinking about the city model, it may be not useful if you only have CityGML city model. It could be a hybrid database, because in BIM, IFC and LandXML has much more information than CityGML for certain elements. So you need to think about different disciplines, how you represent them in the city models. Open data. So if you make a city model, make it available, that will generate new businesses. And for the future of BIM, Of course, it will reduce the cost, increase collaboration, increase understanding, and there's a lot of benefits for the BIM. One thing for the BIM is maybe that you should not be focusing only one discipline. You need to think about the whole project, especially when you will making these huge area planning projects. You need to combine city model, infrastructure, and buildings together, and multiple buildings. So it's much bigger scope then. So you can make one single project model, not only focusing on single discipline. And use open formats, OpenBIM formats, IFC, LandXML, CityGML, and others, because when you go into the future, you maybe need to repair something, you need to get information. So these open formats are the only formats that are machine readable after 20 years or 50 years, because you are planning the infrastructure and buildings for the next 100 years. So you need to be able to access the data later on. So open formats is the only way of going to the future. So maybe the last point is that not only focus on the technology, you need to focus on the people, because BIM is collaboration, and collaboration is about the people. So BIM is only a tool, it's only a pencil, but how you use the pencil is more important. So getting BIM-capable people in the industries, education is important, and also in the companies, giving training to the people in the company so that they are increasing the knowledge of BIM is very, very important. It's very hard to find very BIM-capable, very high-level experts, so we need to increase for training, and also as we as a software company, we need to focus on the user experience, how to make it easy to use, because there are quite many tools, they are very complex and technical. We need to focus on how to make it more easy, like a pencil. Because I think the pencil and paper is the worst competitor to BIM. So we need to make BIM as easy as pen and paper. And start using BIM models. It's fun, it's interesting, it makes your work much more enjoyable. So that's my message. Thank you.
Yes, Mr. Jarkko, we have time for one question from our audience. So, who and how controls the data, project design, or as-built information that is uploaded to the city model?
Of course, the city will take the data and manage the data and store the data and make the process of making it available in the city model. But how to get that data is usually difficult, and that's mostly because of agreements, what the city does with the contractors or designers. So you need to think about the agreements and procurement methods so that the BIM is included there, so that anytime somebody makes BIM model, you deliver it to the city. So that way it's automatic. So designers deliver the BIM model to the city, contractors deliver the as-built data, and even some contractors, they can update the design model into an as-built model and then deliver to the city. So that would be the way.